The purpose of today's lesson is to talk about proportional triangles and slope. We're going to do a little discovering on this first part. We're going to be detectives. Okay, it says on the right, on the line to the right, choose any 2 points that lie on the line. To make your examination easier, choose 2 points that lie on an intersection of the grid lines. Okay, so we're going to choose 2 points, and it's a good idea to choose points that lie on the grid line. For instance, this would be a good one here. Okay, there, and a grid line. I don't know, this guy. We'll just say these 2. Okay, from the 2 points, create a right triangle. The line itself will be the hypotenuse. So this line here is called a hypotenuse, and that's the longest line of a right triangle. Hypotenuse. Sorry, so if this is a right triangle, the hypotenuse is always the longest side. So we're going to connect these 2 so they form a right triangle. All right, we did that. And they showed an example here. Okay. Compare the points that you choose in your triangle with someone in your class. Okay, well, we're not going to do that. All we wanted to do was form a right triangle. And then we're going to do stuff on the next page. But look at this next information. It says, given any 2 triangles with hypotenuse on the given line and legs horizontal and vertical, so remember horizontal is laying down, vertical up, then there is a dilation that takes one on the other. In particular, the lengths of corresponding sides are all multiplied by the factor of the dilation. And so the ratio of the length of the vertical leg to the horizontal leg is the same for both triangles. So we're going to use drawing these 2 triangles to show dilation. Okay, so let's go ahead here. The graphs below have several different triangles formed from 2 points that lie on the line. These triangles are dilations of one another. Remember, a dilation is a change in size. And their corresponding parts are proportional. Answer the questions below about these lines. Okay, for each triangle, write a ratio comparing the length of its legs, height, and base, then simplify the ratio. Okay, in the future, we will refer to the ratio as rise and run. Okay, so let's compare the ratios, or the rise over the run. So in this one, we're going to have 1, 2, 3, 4 triangles in this example. So let's do this first one. Well, let's just stick with the red, and we're going to name this the rise, or the height. If we were to count that, it's going to be 13. And then, of course, the run is 13. So the ratio is 13 over 13 for this first one. Okay? How about the second one? Let's take a look at that. And that's going to be, if we were to count all these, what's your rise there? That's 10. And the run here is 10. So the blue guy is 10 over 10. Then let's go green. To make it a little thicker there. Green, what do we have? How much is this and how much is that? All right. It looks like that is 7 over 7. And then lastly, we have a 1 over 1. Or do a different color. 1 over 1. Let's simplify all these. Let's simplify all of these. So we got this is 1, this is 1, and this is 1, and this is 1. So what this is showing you is with this line, any 2 points, if you form a right triangle, you're going to have a dilation of any of the other triangles. All right, let's try this next one. Let's figure out what this is. What's this rise and what is this run? That's a lot of counting. But it happens to be 5 over 15. So the first one is a ratio of 5 to 15. The next is, how much is that? Up, how many, and over, how many? What do you see there? Yep, that's 4 over 12. And then the next would be, what do you think that could be? It looks like 3 over 9. And then lastly, what do we have here? What's that one? That's a 2 over 6. All right, let's simplify all these. 1/3, 1/3, 1/3, and 1/3. So the ratio of rise over run, or height over base, is 1 to 3. You see how this is happening? So it doesn't matter what triangle you use. This is what's going to happen. Okay? How about you try these next two? I think you can handle this. So 5 and 6 on your own. All right, 5 and 6. All right, let's answer this question. Do the ratios, rise over run, rise to run, always simplify to the same fraction? Even quadrants with negative ordered pairs, why or why not? And yes, they will always simplify because the dilations are consistent. The dilations are consistent. So it's always going to be the same thing. And this tells us that the triangles are similar. And you'll learn more about this in geometry. Are similar, which means the parts are proportional. Parts are proportional. And the ratios are equal. And what that means with the parts are proportional is you saw that happening. It was 5 over 15, 4 over 12. Those parts would be proportional. Okay, now we got something a little trickier happening here. We are going to find the ratios of these two, and let's compare them. Okay, so pause this, and then you're going to resume, and you'll see if you get the same answer as me. All right, did you come up with the same thing I got? Okay, so our ratios for both of these lines, or the triangles, is 3 over 4, both times. But wait a minute, these lines are a little bit different. What do you know? What can you tell me about this? Well, here's our discovery. If a line is going downhill, left to right, so you always have to think left to right, this is going to be a positive slope, or it's going to be a positive rise over run. If a line is going uphill, we always have to think left to right, just like you read left to right. If it's going uphill, oh, I did that backwards, my bad. That should be negative. Silly me. It's a negative slope. That's going downhill. And then if you're going uphill, you're going to have a positive rise over run. So rise and run over run and slope are the same thing. How can we differentiate? Well, just know that if it's going downhill, make sure it's a negative slope. Okay? How does the rise related to the run of a negative slope affect the steepness of the line? Well, the steepness doesn't change. The steepness doesn't change. It doesn't change. The negative slope just means it's going downhill. Negative slope means going down. And remember, it's always left to right. You have to keep that in your mind. Okay? Okay, we have some more ratios happening here. Okay, go ahead and find the ratios of the three triangles. So let's call this triangle 1, triangle 2, and triangle 3. So find your ratios. Same thing here. We got little triangle, then 2, 3. So this one has 4 ratios. Go ahead and find those. And then answer these two questions. So far you had to do 5 and 6. So let's highlight here what we need to do on your own. So on your own, 5, 6, 14 through 17. Okay? And this concludes our lesson on proportional triangles and slope.